Now we will do problem based on limit as a sum. So the first problem is find the limit from 1 to 3 of the function x as limit of a sum. So just see how can we do it. Let f of x is equal to x. As it is a polynomial, so it is continuous on closed interval. Now we will divide 1 and 3, 1 to 3 closed interval into n congruent subintervals that is of equal length, and length of each subinterval is given by h is equal to b minus a over n, 3 minus 1 over n, that is 2 over n. As we see here, a is 1, b is 3, and f of a plus iota h is equal to f of 1 plus iota h, that is x, that is 1 plus iota h. Iota, sorry, not iota, that is ih. Iota means under root minus 1. But this is the I, symbol I. So it is not iota. So according to definition of limit as a sum, a to b fx dx is equal to limit n tends to infinity h sigma I1 to n f of 1 plus ih. Here we write h because b minus a over n is equal to h. So here value of h is limit n tends to infinity, value of h is 2 over n, and sigma I1 to n f of 1 plus ih is 1 plus ih. So we write 2 over n limits n tends to infinity 2 over n sigma I1 to n 1 plus sigma I1 to n ih, not iota, sorry, ih. Now the next one is limit n tends to infinity 2 over n. Now n is 1 is repeated n times, so it becomes n into 1, that is n, and plus sigma ih is h is common out, and in the bracket we get 1 plus 2 plus 3 up to n. So as defined in the earlier topic, we know the how can we write the sum of 1 plus 2 plus up to n, that is n into n plus 1 by 2. Therefore, limit a to b f of x dx is equal to limit n tends to infinity 2 over n in the bracket n plus h is replaced by 2 by n, and series is replaced by n into n plus 1 over 2. So we get limits n tends to infinity 2 plus 2 over n into 2 over n into n plus 1 over 2. So we get limit n tends to infinity 2 plus n is cancelled out by n, 2 is cancelled out by 2, so we get 2 over n into n plus 1. So we get limits n tends to infinity, 2 plus 2 over n into n plus 2 over n. So we get limits n tends to infinity, 4 plus 2 over n. As n tends to infinity, 1 by n tends to 0. So we get 4 plus 2 into 0. That is, we get 4. So, value of function from a to b, f of x dx, which is equal to from 1 to 3, x dx is equal to 4 by limit as a sum. Now the next problem is obtain integral minus 1 to 1 2 raised to power x dx as a limit of a sum. For a greater than 0. Now the solution is, let f of x is equal to 2 raised to power x is continuous on minus 1 to 1. That is the first step. This is a raised to power x function that is a continuous on minus 1 to 1. Divide minus 1 to 1 into n congruent subintervals length of each interval is that is h is equal to b minus a over n. That is 1 of minus 1 over n. That is h is equal to 2 over n. Here a is equal to 1 and b is equal to a is equal to minus 1 and b is equal to 1 because they are minus 1 to 1, so a is minus 1. And f of x is equal to 2 raised to power x, then f of a plus ih is equal to f of minus 1 plus ih is equal to 2 raised to power minus 1 plus ih, that is 2 raised to minus 1 into 2 raised to power ih. We get 2 raised to power ih over 2. So as we know that as n tends to infinity, h tends to 0. Now, using the formula limit as a sum, integral minus 1 to 1 2 raised to power x dx is equal to limit h tends to 0 h sigma I1 to n f of a plus ih, that is integral minus 1 to 1 2 raised to power x dx is equal to limit h tends to 0 h into sigma I1 to n minus 1 plus ix, that is limit h tends to 0 h into minus 1 plus f of minus 1 plus h is that is f of minus 1 plus h is, we get 2 raised to power iota h, 2 raised to power ih over 2 with summation I1 to n, as to solve the value of f of minus 1 plus ix to make the question easy. Now from here if we see, we will get 2s common, that is in the denominator, and we will remain with sigma I1 to n 2 raised to power ix. So in the next step we will open it. We will get 2 raised to power x plus 2 raised to power 2x plus so on 2 raised to power nh, that is a plus ar plus ar square, that is the GP series. So here we get limit h tends to 0, h over 2 a into, that is 2 raised to power h, r raised to power n minus 1, that is 2 raised to power nh, r raised to power n. R is second term divided by first term, that is 2 raised to power 2h over 2 raised to power h is 2 raised to power h. So r raised to power n is 2 raised to power hn, that is 2 raised to power nh, minus 1 over r minus 1. So we get limit x tends to 0, 1 over 2, 2 raised to power x into 2 raised to power nh minus 1 over 2 raised to power h minus 1 over h. Now as we know that limit 2 raised to power h minus 1 over h is log 2. So we get limit x tends to 0, 1 by 2, 2 raised to power h into 2 raised to power nh minus 1 over log 2. And we know that value of nh is, we get from here, that is value of nh, that is h is equal to 2 by n, so nh is equal to 2. Or we can replace h by 2 by n, then n and is cancel out. So we get limit h tends to 0, half 2 raised to power h into 2 square minus 1 over log 2. E is the base, that is a natural base. So we get minus 1 to 1, 2 raised to power x dx is equal to half limit 2 raised to power x, 2 raised to power 0, that is 4 minus 1 over log e 2. So we get 3 over 2 as 2 raised to power 0 is 1 into 1 over log e 2. So this is the value of limits as a sum for minus 1 to 1, 2 raised to power x dx is equal to half 3 over log e 2. That is the required answer to find the definite integral of 2 raised to power x dx in between the limit minus 1 to 1. Now the next problem is obtain a to b sin x dx as a limit of a sum. Solution: here f of x is equal to sin x is a continuous function on closed interval a to b. Now the second step, divide closed interval a to b into n congruent subinterval length of each subinterval is h is equal to b minus a over n, that is nh is equal to b minus a. that is A is equal to B plus NH. That is B is equal to A plus NH by taking A on this side. So, also F of A plus IH is equal to sine of A plus IH. So, as limit n tends to infinity, h tends to 0. So, let's start by definition of limit as a sum. A to B sin x dx is equal to limit h tends to 0 h summation I1 to n f of A plus IH, that is limit h tends to 0 h summation I1 to n sin of A plus IH, that is limit h tends to 0 h sin of A plus h plus sin A plus 2h plus so on sin of A plus nh. So if we see, we can use the standard result of this sine series and we get integral A to B sin x dx is equal to limit h tends to 0 h cos of A plus h by 2 minus cos of A plus nh plus h by 2 over 2 sin h by 2. That is, we get limit h tends to 0 h cos of A plus h by 2 minus cos of A plus nh plus h by 2 over 2 sin h by 2. As we know that limit h tends to 0, sin h over h is equal to 1, therefore limit h tends to 0, cos of A plus h by 2 minus cos of A plus nh plus h by 2 over sin h by 2 over 2 into h. So we multiply and divide h by 2 into 2. That is, we will get 2 is cancelled out by 2 and we will get cos of A minus cos of A plus nh is b plus 0 over 1 as A plus nh is equal to b and sin h over h for limit h tends to 0 is 1. That means sin of term here over that term, then its value is 1 if h tends to 0. So we get integral A to B sin x dx is equal to cos of A minus cos of B. So if you see cos of A minus cos of B. Now from the above example, if we see simple integration of sin x dx is minus cos x. So what is going to be happen when we have a limit, that is a to b sin x dx? Then we have result cos a minus cos b, and either we get the result minus cos x. So if we see, we have done upper limit minus of lower limit. Then what happened? That is cos of a minus cos of b. So if we have integration of fx dx, a to b is equal to f of x, a to b, then we will get its value f of b minus f of a. So this is all about the definite integral of limit as a sum.